All right, so we're going to derive this identity that n choose 0 minus n choose 1 plus n choose 2 minus dot dot dot, and then plus negative 1 to the n of n choose n is equal to 0 for all n greater than or equal to 1. Because of course it's not going to work if n was just 0, because 0 choose 0 would be 1 and 1 does not equal 0. Right, so we need to make sure that its n is greater than or equal to 1. And the hint is we're going to let a equal 1 and b equal negative 1 in the binomial theorem. So remember, the binomial theorem states that for any a and b in the real numbers, right, a plus b to the n is equal to the sum from 0 to n of n choose k, a to the n minus k times b to the k, and this works for all n greater than or equal to 0. All right, so clearly it's going to work for n greater than or equal to 1, right? So we're going to use our hint here. That'll give us our 0, right? So proof. So we have 1 plus negative 1 to the n is equal to the sum from 0 to n of n choose k. So a is 1, so this is going to be 1 to the n minus k, and b is negative 1, so it's negative 1 to the k. Of course, 1 plus negative 1 is 0, so, and 0 to the n is still 0, right? So this is going to be 0 is equal to, so let's look at the first term of this series. So it's going to be n choose 0, and then 1 to the n minus 0 is 1 times itself n times, so it's going to be 1. And then negative 1 to the 0 is still 1, so it's n choose 0. And then it's going to be plus, right, because it's the sum. So it's going to be n choose 1, 1 to the n minus 1, which is of course 1, and then times negative 1 to the 1, so that's going to be negative 1, plus, so it's going to be n choose 2, right? 1 to the n minus 2, which is 1. Negative 1 squared is 1. So we're good here. Plus, dot, dot, dot. And then plus, so it's going to be n choose n for our last term. And 1 to the n minus n is 1 to the 0, which is 1. And then it's going to be negative 1 to the n, right? So now we have 0 is equal to n choose 0. It's going to be minus, right? N choose 1 plus n choose 2. And then we know the next term is going to be minus, so minus, because every alternating terms, right? Each time it alternates, the sign changes, right? And then it's going to be dot, 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 plus, and it's going to be negative 1 to the n times n choose n. And that's exactly what we wanted to show, right?